Okay guys, so we have been talking about factoring quadratics for several weeks now. And factoring quadratics is something that's going to come into play when we start solving quadratic equations. But this week we're going to shift gears, we're going to back up a little bit, and we're going to talk about what quadratic form actually is and how it looks. So remember at the very beginning of the year we talked about the four families that we were going to focus on this year. We talked about absolute value, we talked about linear, we talked about exponential, and the one that we haven't really covered yet is quadratic. So we're going to talk about it. We're going to go through several types of notes and things. So we're just going to get started on this today. Okay, so originally we have talked about standard form for a quadratic equation. So standard form is going to be y equals ax squared plus bx plus c. So x, of course, can be any variable. A, b, and c are all numbers. So a and b are coefficients and c is a constant. All right. And of course you can have a subtraction symbol here, but all it means is that that number or that term is negative. Okay. So standard form looks like this: ax squared plus bx plus c. Okay. We also talked about at the beginning of the year that when we graph a quadratic equation, it creates a U-shaped curve and it's called a parabola. Okay, so that is the basics that we've already covered. Okay, all right, so if you were to plug into your calculator a quadratic equation, so for example, if I plug in x squared plus 2x minus 5 into the calculator, I'm going to get a U-shaped curve. All right, so we're going to do that on our calculator, and you can do Desmos to do this, desmos.com. Remember we talked about Desmos before. desmos.com. Okay, so Desmos is where you can go and you can actually type it straight in and it will graph it for you. Okay, so we're going to go to our y equals. We are going to plug in x squared plus 2x minus 5, and we're going to press graph. And you're going to see this graph on your screen, okay, or on the computer or wherever it is that you're looking on Desmos or on a graphing calculator. Okay, so what you end up with is this right here. We can actually just kind of casually draw it into our notes. All right, it doesn't have to be perfect. And then if we plug in the next one, all right, and I'm just going to do it on a different line, we have negative x squared plus 3x plus 7. And if I graph that, all right, I end up with, and this is going to be the red parabola, all right, a line that goes like this. Okay, all right. So what we see here is that one is opening up and the other is opening down. And there's going to be a reason for that. So if you look at your notes here, all right, if a, all right, that's this number right here, the number in front of your first variable. If a is a positive, then the parabola opens up like a smile, okay? And if a is negative, then the parabola opens down like a frown. All right, so notice that this is a positive 1 here. Remember, there's not a 1 there, but we know that it's there. It's imaginary. So it's a positive 1, so it's opening up like a smile. This one has a negative 1, so it's opening down like a frown. Okay? All right, so those are kind of the basics of what the parabolas look like. Now, there's a few other terms that you do need to know about quadratics and about parabolas. So the first is an axis of symmetry. Okay, so an axis of symmetry is the vertical line, remember vertical means up and down, that divides the parabola into two equal parts. And you have dealt with symmetry in the past, so that shouldn't be anything too new to you, okay? But there is going to be a line of symmetry on each of these. Now my picture doesn't do it justice because mine are not equal on both sides just because of human error. But if you draw this perfectly, exactly like it's supposed to be, then you will have two equal parts on either side of that axis of symmetry. Okay, so to find the axis of symmetry, we use this formula. X is equal to negative b over 2a. And when we are graphing a line, remember that x equals means that we're going to have a vertical line, and that's why it's x equals here. And you're just going to plug in negative b over 2a. This is b and this is a, remember, to find out what that axis of symmetry is going to be. Okay? And I'll show you a few examples of that here in just a minute. The final example, the final definition that you need is vertex. Vertex is the turning point. And we've talked about turning points. We talked about that when we were discussing our vocabulary at the beginning of the year for these types of equations. So this is the turning point of the parabola. It's where it changes direction, okay? So if the vertex is the lowest point, it's called the minimum. Remember, we have discussed this before. This should be review. And the highest point is called a maximum. So in those examples that we had up here, this would be considered the minimum, the lowest point, the vertex. This is the maximum, the highest point, the vertex, okay? All right, so let's look at one example and then we'll talk about a few more examples here in a minute. So we are going to find the axis of symmetry and the vertex and then sketch the parabola. Okay, so here is our formula, our equation, y equals x squared plus 8x plus 15. So this is going to be a, this is b, and this is c. So a is equal to a positive 1, b is equal to 8, and c is equal to 15. So far we know that a is positive, so it's going to open up like a smile. All right, and now we need to find an axis of symmetry. So we're going to use the formula. So x equals negative b over 2a. So negative b is 8. Okay, notice that I put b in parentheses because if this were a negative, that negative would still stand and it would cancel them out and make it positive. So you have to have this number in parentheses. Okay, so this number is 8. We divide by 2, multiplied by a, which is 1. So we end up with negative 8 divided by 2, which is negative 4. So that means that the axis of symmetry is going to be on the vertical line x equals negative 4. Okay, and then we have a vertex, which we are going to find. Okay, so if I know that x equals negative 4, I can go ahead and plug it into that point. And then to find it, mathematically, we're going to plug it into this original equation. So y is equal to negative 4 squared plus 8 times negative 4 plus 15. So all I did was take this original equation, and every time I see x, I plugged in negative 4 because I know that the vertex has to be on the axis of symmetry, so the x has to be negative 4, and I want to know the one place where y is what y is going to be equal to if I plug it in. Okay, so negative 4 times negative 4 is 16. 8 times negative 4 is negative 32 plus 15, and if I simplify all of that, I'm going to get negative 1. So when x is negative 4 on the graph, y is going to be negative 1. Okay, so when I graph that, it's going to look something like this. So I'm just going to do a brief sketch here. All right, I know that negative 4, 1, 2, 3, 4 is going to be my axis of symmetry. So it's going to look something like that. And my vertex is at negative 1, and I know that it opens up. So I'm going to draw it just like that. And I know that's not the best example, not the best picture, but we're going to do several more examples that will hopefully make that a little bit easier to view. Okay, so axis of symmetry is here. Your vertex is that lowest point, all right, and it's opening up. So that's what it's going to look like. Okay, so coming at you with a few more examples. Just be ready to check those out.